Dear viewers, very good morning to all of you. Myself Sukhvinder Pal Singh, Senior Lecturer, Department of Electronics and Communication Engineering, Government Polytechnic College for Girls, Ludhiana. I am here on behalf of Department of Technical Education Punjab and Punjab EduSet Society to discuss about the topic of GSM and CDMA, which is in the course curriculum of wireless and mobile communication of 6th semester of 3-year diploma in electronics and communication engineering as approved by Punjab State Board of Technical Education and Industrial Training, Chandigarh. So, what are GSM and CDMA? These are most common factor these days, because everybody uses mobile these days. Everybody in our country has, some person have more than one SIM, more than one mobile sets, and everybody talks about GSM and CDMA, that one mobile or one company is using GSM technology and other is using CDMA technology. So, what are these both? We will discuss in this lecture. First of all, we will discuss about GSM and later on about CDMA, then we will compare about both, and if the time permits, we will try to discuss about the mobile tracking, which is a very common feature during some crime scenes or during a lost or any theft of mobile system. So, first of all, we will discuss about GSM. GSM, its full form is Global System for Mobile Communications. Basically, it is a standard used for communication in mobile. It is working on open digital cellular technology, and it is used to transmit mobile voice and data. Nowadays, very large data like picture, audio, SMS, etc., MMS, and much more uses value added services are there in mobile system. It is originally driven from group spatial mobile, because when wireless technology was invented, wireless communication was invented, it takes almost 100 years to go for a common standard in mobile communication, and first common standard used in European countries, it was group spatial mobile, the most popular standard for mobile phones in the world. Now, GSM has several more features than this group spatial mobile, and that is why it is known as global system for mobile communications, and it is considered as second generation, that is 2G system. The spectrum used in this case is 2G spectrum. The features of GSM: it is basically an international standard for mobile service. It offers number of services like voice, SMS, fax, voicemail, call forwarding and caller identification, etc. It has high mobility, it has higher capacity, and it has worldwide roaming, because this standard is now acceptable internationally. So, the person having the mobile phone of any company of anywhere in the world which uses GSM technology, it can be taken to any other country in the world which uses GSM technology, and the phone will work. Perhaps some formalities like identification, etc., and some security may be there. Otherwise, all GSM phones are acceptable worldwide for roaming. Now, we will discuss about frequency bands in GSM. In GSM, there are three types of frequency bands. These are dual band, tri band, and quad band. First of all, we will discuss about dual band. As the name implies, it will operate on two frequencies. So, this dual band GSM, it operates on 900 megahertz and 1800 megahertz. These are the two standards frequencies which are used in various countries. Some countries use started on 900 megahertz, and some other countries they started on 1800 megahertz. To make internationally common feature, so dual band was first of all introduced, which was operating on 900 megahertz and 1800 megahertz frequencies. The mobile phone supporting dual band can be used in world where 900 megahertz and 1800 megahertz frequencies are used. This kind of system, that is dual band, they are found in all continents of world, that is Europe, Asia, Africa, Australia and South Africa. In these countries, either 900 megahertz is being used as a frequency carrier, or 1800 megahertz is being used. So, this kind of GSM mobile, it works all over the world where 900 megahertz and 1800 megahertz frequencies are being used. Next is tri-band. As the name implies, it has three frequencies. So, three frequencies are supported in tri-band. Two are the common, that is 900 megahertz, 1800 megahertz, and one extra band, that is 900 megahertz frequency. It was earlier used in American countries. So, it was the GSM tried to be acceptable in that countries also. So, it also included one more frequency, that is 1900 megahertz. So, it is also supported worldwide. Then quad band, as the name implies, there will be four frequencies supported in this kind of band. The three frequencies are as in the tri band, that is 900 megahertz, 1800 megahertz and 1900 megahertz, and one more frequency band, that is 850 megahertz frequency, that is also acceptable in quad band. So, with the countries which started very earlier and was using frequency carrier of 850 megahertz, so they were also included in this kind of GSM system. So, the quad band is also supported worldwide. Now, we will discuss about the GSM architecture. In GSM global system for mobile network, there are following areas. Number one is cell, then location area, then MSC or VLR service area, and PLM, and we will discuss one by one to all these areas. First of all, what is cell? It is the basic service area which is covered by one BTS. BTS is base transceiver system. So, the cell is the basic service area, because total service area which is being serviced by one company or one service provider, it is divided into certain areas, certain then one big area is there, then small areas are there, and then that small areas are again divided into the basic service areas, and that service area is known as cell. The geometrically it is drawn as in a hexagonal shape, which has a basic cell. Each cell has unique number, which is known as cell global identity. Each cell or each basic service area, it has a unique number. It is provided by the service provider, or we can say it is given a cell global identity by a committee which controls all the mobile services, so that there is no interference between the other between any company, because some company may think that this is one cell and some were thinking that this is one cell. So, to avoid the problem of interference between each other, so international committees, they allotted unique number to each cell, which is known as cell global identity. Each area, each mobile, each SIM, they all have a unique identity, which we will discuss one by one. The next is location area. Sorry. The location area is a group of cells. The many group of cells, because in one city there can be many cells, and one city can be allotted one location area or more than one location area. So, one location area is a group of cells, and the area that is paged when a subscriber gets incoming call. When the subscriber gets that subscriber is paged that it is having getting an incoming call. So, this location area is paged and each location area is provided a location area identity. First we will we were seeing that each cell is allotted a cell global identity, and now we are seeing that each location area is allotted a location area identity, and it is served by one or more BSC, because in one location area there can be one or more BSCs depending upon the number of subscriber having mobile phone in that area. Then PLM, it is a total area covered by one network operator, and it can contains one or more MSCs. MSC are the main switching centers, which are the main switching center or main service switching centers, which are having the all detail of mobile subscriber and all detail of their phone calls and all detail of roaming, etc. Now, GSM architecture, it can be seen in this diagram. Here, first of all, it is divided into three systems, three parts it is being divided. First is base station subsystem, which contains BSC, BTS and MS. The MS is the mobile station, which is basically the mobile phone set, and the SIM, which we all have in our pocket. So, the mobile station, it can be in any moving vehicle, or it can be stationary, or it can be in a walking, it can be with a walking person or a stationary person, or it can be in a moving vehicle, like these two mobile stations are shown here. One is stationary and one is in a car. Then these are connected to BTS, that is which the MS is connected to which cell. Then these again, these cells are connected with BSC, and this is the one part, that is base station subsystem, and other part of GSM system architecture is network switching subsystem. The network switching subsystem, it contains the MSC, main switching center, then HLR, home location register, VLR is visitor location register, and AUC is the authentication, and other is operation support subsystem. OMC is attached with the MSC, and it is also attached to the BSCs attached with this system. And then again, next part is public networks, which are the public switching telephone networks, integrated service digital network, and data networks, which are the our we can say landline or basic phones, or the basic companies, which are public networks, where these are connected to the our mobile system through this process. That our mobile system is first attached to one BTS, then this is to BSC, and BSC through OMC to the MSC, and MSC is again attached to the public networks like PSTN, ISDN and data networks. We will now discuss about the GSM network stages. As we have already seen that GSM network has 3 stages. One is base station, then network switching and then public network. The mobile service switching center MSC, it performs the switching of calls between the mobile and network users, and also there is management of mobile services such as authentication. It is there in the mobile service switching center. Now we will discuss all the 3 subsystem of GSM network. First of all, in the base station subsystem, the first part is mobile station. The mobile station consists of the physical equipment. It is the radio transceiver. The mobile set we have, it is also having the transmitter as well as receiver. So it is a radio transceiver. It has digital signal processors and it has a SIM card, that is subscriber identity module, and the SIM provides personal mobility because each person has its personal record in one SIM. So personal mobility is there because if we insert SIM into another phone, then again that number which we have, our personal number, that works in that mobile station. Again the same SIM subscriber identity module. By inserting the SIM card into another GSM cellular phone, the user is able to receive calls at that phone. This is the basic diagram, and these BTS, these hexagonal system, they are the cell area, and each base transceiver subsystem or base transceiver station, they are the controller of each cell area. These 3 hexagonal shapes are shown. These are the cells, and each cell has one BTS, and again there are many mobile stations attached to one BTS. This is again attached to a BSC. Now, as the cell and the visitor location area have their personal or the unique identity, the SIM card also has unique identity. The SIM card contains the international mobile subscriber identity, IMSI, the SIM card has. So this identity can be located anywhere in the world. The SIM card may be protected against unauthorized use by a password or PIN number, that is personal identity number. The user can himself make a PIN number or personal identity number, and it can be protected against unauthorized use. Then base station subsystem, it is composed of 2 parts: base transceiver system, base transceiver station and base station controller. BTS and BSC are 2 main parts of base station subsystem. The BTS, it handles the radio link protocols with the mobile station, because each BTS is attached to the first network or first station which is attached to our mobile station, that is BTS. So the base transceiver station, it handles the radio link protocols with the mobile station. Then BSC or base station controller, it handles radio channel setup, because the call processing, it is controlled by the BSC or base station controller. It handles radio channel setup, how one channel which is on which the call is to be made, it is provided by this base station controller, because there are many mobile subscriber which are trying to call at a time. So, to control over the call setup, the base station controller, it controls how, which channel is to be, which radio channel is to be provided for which, because in case of busy hours the channel from nearby cells can also be allotted for call setup, which is so one mobile station we are generally if we see cell info, then at one point we are having the cell info of almost 3 cells at a time, because when the base station controller, it tries to connect the mobile station with these the 3 adjoining cells, so that when the person is moving from one point to another point, so between this there is a handoff is required, that is handing over of call from one cell to another cell. So, the base station controller, it is already watching that the person is moving from which cell towards which cell. So, the radio channel setup is to be provided by a controller, that is called base station controller, and frequency hopping is also there. It is controlled, it is handled by the base station controller, and handovers, that call from one cell to another cell is handed over, that is also controlled by the base station controller. Basically, base station controller, it is the connection between the mobile set and the mobile service switching center MSC. Here in the diagram we can see that these BTS are connected with the mobile stations, and this is controlled by BSC, and this is connected to the MSC, that is mobile service switching center or main switching center. There can be one or more MSCs in one network or one service provider. So, sorry. So, one we can say that the base station controller, it is the basically the connection between the mobile and the mobile service switching center, that is MSC. The functions and physical elements located in a BSC and BTS. So, we will see in detail with what are the basic functions and what are the physical elements located in a BSC as well as in BTS. So, here we will see that in base station controller, it has BSC processor and control of BTS. The BSC processor, it controls the base transceiver stations. It has radio resource management, that is which channel or which radio channel is to be allotted, which is available and which is to be allotted to which mobile station according to the need and according to the rush of calls. It is the function of base station controller, that it allots or it manages the radio resources. Then handoff management and control. The handoff or the handover of call from one cell to another cell is also controlled in base station controller. Then the functions and physical elements of present in base transceiver station. The BTS contains BTS processor, it has radio transceivers, that is radio transmitters are also there, radio receivers are also there, then equalizers, channel coders are there, because it has to code the different channels, then transcoders are there, encryption unit is there for security, the coding is there, then interleaving and de-interleaving is there, combiner is there, and pre-selector is there. The pre-selector and combiner, these are the basic processors for the call processing, because when the a person starts dialing a number, through their microwave signal or radio receiver, the BTS gets the information that this mobile set has pressed these numbers, and it again tries, starts its own work, the pre-selection of channel, that which channel are available there, and it gives information to the BSC that this mobile station has pressed, and it can call, because before calling the before pressing the call button in a mobile station, the BTS gives the information to the BSC that this mobile number has pressed this number, and it can call at any time. So, there are the pre-selection movement or pre-selection starts at the moment we press the numbers, either we have pressed the call button or not, because if they select after our pressing of call button, then there can be delay in the resource allocation, that which channel is to be allotted. If they think, the BSC thinks after that, then there will be delay, and then if the call is to be processed to the another MSC or another network service, then another network service provider, then there will be too much delay, and the call may not be completed or may not be processed. So, the pre-selectors and combiners have very important role in BTS. So, next is the mobile switching center, that is MSC. It is the central component of network subsystem. It acts like a normal switching node of the PSTN or ISDN. It acts like the normal switching node with the other public network and its own mobile subscribers. The role of MSC is registration. It registers the each and every data of the user. Authentication, it gives the authentication or authority to process the call, and then location updating is done here. Handovers are also from one MSC to another MSC, or one BSC to another BSC, or one BTS to another BTS. They are controlled in MSC. They are selected by BSC, but they are controlled and they are approved by MSC. Call routing to a roaming subscriber. If a subscriber is roaming in a roaming stage, that is from, it is not its own network service provider area, then call, any incoming call for this subscriber is to be routed from its own location toward the location where he is at a time. The home location register, which is there in the network switching subsystem, it contains all the administrative information of each subscriber registered in the corresponding GSM network and current location of the mobile. All the admin information, we mean that name of the person, address of the person, and its location of the person, and current location of mobile there, and which to which GSM network it is registered, etc. So, all the data, all the admin information, we can say, or personal information of a user or a subscriber is provided in home location register of the network. Visitor location register, VLR, it contains the selected administrative information from the HLR, to call control for each mobile located in geographical area controlled by the VLR. So, visitor location area, it contains the selected information from the home location register, and to control the call for each